Right, in this video, I will continue with the discussion of one-sided limits and continuity, and we go into problem number 33, where we want to discuss the continuity of this piecewise function on the closed interval from -1 to +4. We can see that the left branch is used for x less than or equal to 0, whereas the right branch goes for x greater than 0. So both of them are linear functions and they're both continuous everywhere. The only place we need to be concerned is at x equals 0. So if we were to take the limit from the left at 0, we would get 3. The limit from the right at 0 would be 3 as well, and the value of the function at 0 is the top branch would also be 3. So in that case, number 33 would be continuous everywhere. Once again, a reminder on the definition of continuity. We need the limit as x approaches 0 from the left to exist, which it does, and that's equal to 3. And the limit as x approaches 0 from the right of f of x, and that's also 3. And so the limit exists there. Now, is it continuous? We just need to check the value of the function at 3, at 0. And that's also 3, and so the function is continuous at that point. All right, we'll continue with number 35. We want to find the x values, if any, at which f is not continuous, and then to state which discontinuities are removable. So in number 35, we have a discontinuity at x equals 0, and that's an infinite discontinuity, a vertical asymptote that's not a removable. Number 37, that's just a parabola that's continuous everywhere, so there are no discontinuities. In problem 39, we have 1 over 4 minus x squared, which would factor to plus x plus or minus 2, x plus 2 times x minus 2. And so you'll have vertical asymptotes at positive and -2, and neither of those are removable. For 41, 3x minus cosine of x, both 3x and cosine x are both continuous everywhere, so the difference of the two will also be continuous everywhere. With problem 43, x over x squared minus x, if we factor the denominator, we'll see that we have x over x minus 1, x over x times x minus 1, and the x's would cancel. So we have two types of discontinuities in problem number 43. We have a removable discontinuity at x equals 0, and we're going to have a vertical asymptote at x equals 1. And that does it. I'll scroll down for another problem. 45 is same instructions here. However, note that in this case, the denominator will never equal 0, and so therefore there are no discontinuities in this. In problem 47, we should attempt to factor first, and the denominator factors to be x minus 5 times x plus 2. The x plus 2's cancel, and so this will be another case that will have two types of discontinuities. At x equals 5, we'll have a vertical asymptote, and at x equals -2, we have a removable discontinuity. On problem 47, we have absolute value of x plus 7 over x plus 7. And that's just a transformation of this absolute value of x over x, which was two horizontal lines of -1 and +1, only this is going to be shifted 7 units to the left. And its discontinuity will be at x equals -7, and it's not removable. And we'll continue in the next video.